Okay, welcome to this video. Now we're gonna try to find the domain of this composite function. So it's 3 times the composite of the ln of x. So one good idea to work this problem is we can start by remembering or reminding us of the domain of the natural log. So the natural log is defined on the set of strictly positive integers. Okay, that means the 0 is not included. We can see that graphically if we graph the natural log. So this is 1. So this is the ln of x. Okay, so we know that the limit of ln of x as x goes to 0 from the right is minus infinity, and ln of 1 is 0. Okay, so now the first thing that we need to do is we want to find the domain for this first part. So we know the domain for this one. Okay, so it's this set. Now we're gonna find the domain for the natural log of the natural log of x. Okay, so here this one has to be positive to be able to define this one. Okay, so that means we need to have ln of x bigger than 0. Okay, so this one will help us. The graph here will definitely help us finding the values. This is 1, the values of x which make the natural log bigger than 0. So clearly we see that it's this set 1 up to infinity. So okay, so it's the set 1 up to infinity. And if we don't see it, we can just take the exponential, okay, the inverse function of the natural log. So when we take it, we take e to ln of x is bigger to e of 0. Why? The sign that didn't change, because the exponential of x is an increasing function. Okay, so that means if you have a bigger than b, if you take e to a, is going to be bigger to e to b. Nothing changed here. So now we know that this one is x and e to 0 is 1. This gives us the domain for this one. So the domain for this one is x bigger than 1. Okay, next we're going to find the domain for the whole function. Okay, so that means we need to find the values such that ln of x is bigger than 0. Okay, but we know that this one is the same as ln of x is bigger to the natural log of 1. Okay, so this is clear from the definition here. Next, we're first gonna take the exponent. Okay, so when we do that, we will take e to ln of x is bigger than e ln of 1. Okay, so now what we get ln of x is bigger to 1. Now we take again the exponential. So we get x bigger to exponential of 1. That means the set of values that define this function is given by e is not included, so we'll take it out. So e plus infinity. This is the domain for this function. Okay, so the function is defined, this function f is defined only on this interval, e plus infinity. Okay, we have used many times the inverse function to compute this domain. Graphically, we can also do the graph for the L of x. We can graph it here, okay? And we can see from here the values that would make this one true. So we're looking for L of ln of x bigger than 0. So it starts from e, from this value. Okay? Thank you very much.